First impact. And then what we're able to do now is I got to reposition the gate, bring it down to 2.2. Yes.
We're ready.
3 meters.
As we can see, at the front impact point, the paint finish is slightly damaged, whilst in the inner part, the shell fabrics have clearly worked to distribute the impact over a wider area, thereby dissipating the energy. The inner polystyrene foam shell has made it possible to absorb the residual energy, thereby preventing the acceleration from reaching the rider's head. Again, at a speed of 7.5 meters per second, we have a result of 126 grams, as compared with the 275 grams set out by the regulation, and 831 HIC as compared with the 2400 specified. The helmet is clearly well within the limits permitted by the regulation. The shell must not fracture, but should only suffer elastic deformation. Here we can see that the thermoplastic shell tested with the EPS shell within has suffered no external deformation, but towards the inside we can see the polystyrene foam that has absorbed the residual energy. The visors, molded from Lexan OQ4820 polycarbonate, are also bullet tested.
Nolan è presente un laboratorio autorizzato dal Ministero dei Trasporti che permette di eseguire tutti i test secondo il regolamento EC 2205. In questo caso possiamo vedere un casco testato secondo il regolamento 2205 nel punto frontale B con una condizione di meno 20 gradi.
The typical round and smooth Arai outer shell offers several important advantages. It reduces the rotational forces during an impact, and it offers better aerodynamic properties. The shell is not larger than it needs to be, again increasing the performance of our helmets.
The RX-7 GP and also the RX-7 RC carbon version are the only helmets in the world that meet and exceed both standards, the ECE 2205 and SNEL M2010. We have developed our own standard, what we call the Arai in-house standard. All the helmets that we produce should meet or exceed our own standard, and not only the minimum requirements in each country or continent.
For the Arai in-house standard, we test not only at fixed points like EC, but also at random on a larger area. Besides testing, researching actual crashed helmets from road and track is an important part of our development program. We use these data to improve the performance of our helmets.
When you use an Arai helmet, it comes with a full package of all the support that you need as a user. That means that if you have any problems with your helmet during the 5 years that we guarantee that you can use that helmet, you obviously need to have the knowledge at the dealer and also the spare parts available. We have all the spare parts available at least up to 7 years after we stopped production of a particular model. The emergency release system offers the possibility to take out the cheek pads from a helmet, and this obviously gives more space inside the helmet. So in case of an impact, in case of a crash, marshals or first aid personnel are able to take off the helmet from someone's head without using force to the head.
When HJC committed to creating an all-new premium helmet, the innovative R-P-S 10, the company also made a huge commitment to expanding its facilities and gearing up for the R-P-S 10 production. For years, the HJC plant had already been regarded as one of the foremost helmet manufacturing sites anywhere, in keeping with the company's standing as the #1 manufacturer in the world. But the efforts required to design and build the top-of-the-line R-P-S 10 required a whole new level of expansion. The very first forms of the R-P-S 10 began as design sketches that morphed into CAD designs and interim models built via rapid 3D prototyping. A helmet designer can have many good ideas in mind while sketching up new shapes, but there's really only one way to know for certain if specific elements will achieve the desired results. Build it, test it, then do it again and again. And so HJC engineers embarked on a development process that stretched on for 3 years in the creation of the final product. 3 different development teams worked on various designs during this time, and more than 20 different prototypes were created and tested. Each prototype was thoroughly evaluated, and with each new step, the design was tweaked and reshaped for reduced aerodynamic drag, maximum stability, minimum lift, minimum vibration and noise, and more. Based on these testing results, the existing prototype would be revised, and a next generation prototype would then be designed and constructed, and the testing process resumed once again. In time, the final form was created. As you inspect an R-P-S 10 carefully, you'll note subtle compound curves and complex structures shaped into the upper and frontal areas of the shell. The complexity of the shell shape becomes readily apparent, and for good reason. These shapes play a major role in establishing the correct aerodynamic properties. And that didn't happen by accident. It happened through an inordinate amount of R&D with plenty of the most modern equipment available, plus tons of plain old hard work. In order to conduct such tests, HJC built a new oversized wind tunnel capable of admitting a complete motorcycle and a rider, a substantial commitment in capital outlay and space. Motorcyclists live in a world filled with wind, a wind stream that does not stay constant. Whether the day calls for gentle meandering and sightseeing down a shady country road, or handlebar to handlebar racing at triple-digit speeds, the rider encounters ever-changing wind conditions with the rider's head and helmet constantly taking on different positions. As a result, it makes perfect sense to test a helmet's form for aerodynamic efficiency and stability in a full-size wind tunnel while it is strapped onto a test engineer sitting aboard a motorcycle. And this is what motivated HJC to build such a facility and conduct extensive testing. With the new R-P-S 10, dynamic tests with a helmeted test engineer were performed at wind speeds up to 130 miles per hour. Why such high speeds? Certainly because racers regularly attain such velocities and more. But consider this. Should a rider heading down the freeway at 70 miles per hour encounter strong headwinds of 30 miles per hour or more, such an everyday occurrence easily surpasses the 100 mile per hour mark, which is to say a helmet's superior aerodynamic performance gained through wind tunnel testing at high wind speeds can benefit all riders. And HJC's Design Center also contains one of the most comprehensive testing labs in the industry. Not only does the lab allow for dynamic testing for European and SNEL standards, but it also contains special tests devised by HJC's engineers to ensure quality and durability. With the design finalized, a completely new method of helmet manufacture and production facility had to be devised to produce the R-P-S 10, which is the lightest SNEL 2010 approved helmet on the market. The plant was expanded and the HJC engineers established an all-new manufacturing process, one that incorporates a pre-molding technique to carefully locate and shape the layers of the lightweight and strong premium integrated matrix material with exacting precision.
Go! Go!
There can be no compromise when it comes to safety, the most important function of a motorcycle helmet. Helmets are carefully examined after every portion of the production process to ensure optimal quality control. Approximately 3,000 helmets are destroyed every year in impact testing to ensure that every batch of helmets we produce satisfy the safety requirements of countries around the world, while keeping with our own exacting quality standards. When a helmet is impacted, the shell is bent and an impact is distributed and absorbed. At the same time, the impact absorption liner is compressed and absorbs the impact. Not only is a heavy helmet uncomfortable, but the additional inertia of a heavy helmet can increase the load on the cervical vertebrae in an accident. Shoei strives to produce helmets that are not only lightweight, but strong and rigid as well. Shoei's AIM and AIM Plus shells are formed from a combination of fiberglass and organic fibers, bonded together by plastic resin. These fiber-reinforced plastic shells are both rigid and lightweight. Even if the helmet appears undamaged, the impact absorption liner could be compromised, and thus the helmet should be replaced. Racing models are equipped with Shoei's emergency quick release system. EQ-RS is a mechanism to allow emergency medical personnel to remove the cheek pads from a rider's helmet. This reduces the load required to pull the helmet from the rider's head.